Here we have kind of a classic apple orchard question. The more trees that the farmer grows on a hectare of land, the less apples per tree. And the farmer wants to know what is the optimum amount of apples, or excuse me, apple trees to be grown on a hectare in order to maximize his profit. So we have kind of a lengthy answer here, so try to give you a screenshot of it, an overview before we discuss it. Okay, and now we'll go through it in order. First of all, we know that the number of apples that Clarence has is equal to the number of trees times the number of apples on a tree. Well, he starts with 50, and for every tree he adds, he loses 8 apples from his original 600. So the amount of apples is equal to negative 8x squared plus 200x plus 30,000. Now, the revenue is 15 cents times the number of apples, so distributing 0.15 in, we get this new quadratic. Now, the cost to Clarence of running this operation is $4 per tree. Well, according to what we wrote above, he has 50 plus x trees, so 4 times 50 plus x is 200 plus 4x. Since profit is revenue minus cost, we can say P at x is R at x minus C at x, and distributing the minus sign into the bracket, we get that the profit function is a function of x, and it's equal to this quadratic right here. Now, in terms of our domain, before we take the derivative, we'll consider the domain. In terms of that, we know that the number of trees he grows on his per hectare has to be greater than or equal to 0. So 50 plus x is greater than or equal to 0, which means x is greater than or equal to negative 50. Now, you might say, how could we ever know the maximum number of trees to grow? And we could simply say that the apples per tree has to be greater than or equal to 0. Well, the apples per tree is 600 minus 8x, so in theory at least, x has to be less than or equal to 75. So what we have is a domain of negative 50 less than or equal to x less than or equal to 75. We're now going to take that profit function, take the derivative and set it equal to 0. And solving for x, we get that x is approximately 10.8. Now, keep in mind that our original profit function that we found a while ago is a quadratic. And so by its nature, it's going to be symmetrical. So when we say that x is approximately equal to 10.8, we realize that we can't grow a non-integer number of trees, so x has to be 10 or 11. Well, we know that x has to be 11 because that vertex is going to be closer to 11 than it will be to 10. So we know that x is 11. If that's going to be our maximum profit, it'll be that number, not 10. So now what we're going to do is plug in the two endpoint values for x, which are negative 50 and 75. Our profit is 0 if he plants 0 trees. That kind of makes sense. The profit is negative 500 if he plants 75 trees because he doesn't get any apples, but he still has to pay, if he grows 125 trees, he doesn't get any apples, so there's no revenue, but he still has to pay $4 per tree, which would lead to a profit of negative 500. Well, those are both bad options, but when he grows 11 extra trees, he has a profit of $4,440.80 per hectare. But that doesn't mean he's growing 11 trees. That means he's growing 11 extra trees because the number of trees is 50 plus x. And so the number of trees is 61. And in order to maximize profit, Cornelius should grow 61 trees per hectare.